How's it going, everyone? Welcome back to Quarantine Science. The learning target for this video is just going to cover how to draw atoms or specific elements based on their location in the periodic table and the information that's provided to us in their element boxes, such as the atomic number and the atomic mass. If you watched the previous video before this one, we went over what those numbers means and how you can tell how many protons, neutrons, and electrons an element has. But for this video, I'm just going to focus how to draw them in a bit more of a specific manner, where that's going to be the only thing that we cover today. If you need to know more, go back and watch that video. Let's go ahead and get started. If you have your periodic table handy or one that you can look up, go ahead and look it up really quickly so we can look up that information. I'm going to use my tiny one over here off to the side. Helium has an atomic number of 2. That means helium has, 2 protons and 2 electrons. And it is in period 1, which means it's going to have 1 energy level. It is the second element in this row. If we look on the periodic table here, it goes 1, 2. So it is only going to have 2 electrons in that energy level. Now we need to figure out the number of neutrons. So to figure out the number of neutrons, we need to look at the atomic mass. And if you look up your periodic table, it says it has an atomic mass of 4.0026. So we're just going to call the atomic mass equal to 4. And in order to find the number of neutrons, we need to subtract that number from it. So 4 minus 2 from the atomic number, that will get us, it has a total of 2 neutrons. Okay, now that we got that information, let's go ahead and draw this. So helium had an atomic number of 2. It's going to have 2 protons. I'm going to take the time to actually draw this. So we'll draw them like this. After subtracting the atomic mass from the atomic number, we found that it had 2 neutrons. And from the atomic number, we figured out that it has 2 electrons total, and since it's in period 1, that is that first row, it's only going to have 2 electrons in that one shell. 2 electrons total. Period 1 means it only has 1 energy level filled with electrons, and since it is only the second element total out of the 2 elements there in that first row, it's going to have 2 electrons in that energy level. That's it. That's helium. Fluorine has an atomic number of 9. So that means it has 9 protons and 9 electrons. It has an atomic mass of 18.998, so we're going to round that to the nearest whole number, so it has an atomic mass of about 19. Now we can figure out the number of neutrons by subtracting the atomic number from that, so we'll go minus 9, put a star there so we know where that comes from. And then 19 minus 9, what that means, it has 10 neutrons total. So this is in group 2, it's in the second row. Or period 2 means it's in the second row. So period 2 means it has 2 electron energy levels. And let's see here, it is 1, 2, 3, 4, 5, 6, 7 elements into this group, into this row. So that means that it is only going to have 7 electrons, or not only, it's going to have 7 electrons in its outermost shell. So, 7th, we'll call that the 7th group, means 7 electrons in outer shell. Okay, let's go ahead and take a moment and draw this. Okay, we'll draw it out really quick here. To save time, I'm just going to write out the numbers. This is going to have 9 protons and 10 neutrons. I'll put a 0 there so we know it has a net charge of 0. And it's going to have 2 energy levels in the first one here. How do we know how many electrons go into that first level? Well, we just take a look at the periodic table. There are 1, 2 elements in that first row. So in that first energy level, only 2 electrons are going to go there. Now, because this has 9 protons, it means it's also going to have 9 electrons in it. So we'll draw that second energy level. And we'll add in the electrons here. So it's going to have, we have 1, 2, and then it's going to have 1, 2, 3, 4, 5, 6, 7 electrons in its outermost shell. So we'll go ahead and draw that. So 1, 2, 3, 4, 5, 6, 7. Oops. 9 total. All right, that's fluorine. Okay, potassium has an atomic number of 19, which means it's going to have 19 protons and 19 electrons total. Okay, next one we're going to look at is the atomic mass, and that is 39. We'll subtract the atomic number from that, minus 19. That's where that came from. That gets us, let's see here, 20 total neutrons. Okay. It is in group 1, which means it's going to have only 1 electron in outer energy level. And it is in period 1, 2, 3, 4. So it's going to have 4 total electron energy levels. All right, that is all the information we need. Let's go ahead and draw this. Okay, for this, again, I'm only going to just write out the numbers. So it's got a total of 19 protons, and plus 20 gets us to 39, so 20 neutrons. We'll go ahead and draw our first energy level here. This is going to be a big one. I might have to move this label here. It's got 2 electrons in that first row there, so we're going to have to put 2 electrons here. We've got a second energy level now. There are 1, 2, 3, 4, 5, 6, 7, 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. That is, we have 8 electrons in this energy level because in this row 1, 2, 3, 4, 5, 6, 7, there are 8 elements in this period, in this row right here. Okay, we got a third group here, a third period, third row, before we get to potassium, so we got to draw that. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8 electrons in here as well. I'm going to offset that a little bit so that doesn't look so weird. 3, 4, 5, 6, 7, 8. Okay, we're almost done here. We've got one more energy level here where potassium is. And this is in group 1, so it's only going to have 1 electron in its outermost shell. I'm just going to draw that right here. Take a moment and count it up to make sure we're right. So we got 2 energy levels of 8. That comes out to 16, 17, 18, and 19 total. Okay, that's all for today's video. Thank you for watching. Please like and subscribe if you found this helpful. I'll post a link to the other video at the end of this one if you would like to review a basic periodic structure. Thanks again for watching. Have a great day.